we've already looked at maps extensively in Tableau, and we've talked about some of the things Tableau is good at doing, but we haven't really said too much about what it doesn't do. It's important to realize that Tableau is a wonderful tool for displaying your data, whether it comes in the form of a spreadsheet or a spatial file. And it is very good at giving users options for how they want their maps to look, what layers they wish to include, what data variables they wish to highlight, and so on. It is also incredibly easy to use. It's a drag and drop system. Once you know a few tricks, you can generally figure out how to display your data in a way that's pleasing to you. The great limitation of Tableau, of course, when it comes to geospatial data is that it can't make new maps. It can connect to spatial files or to servers which display maps, and of course it comes with hundreds of thousands of preloaded shape files which can generate for all kinds of geographical features. But you can't actually generate new data, new spatial data using Tableau, just display features of existing ones. This is analogous to the other functions of Tableau. To display quantitative data, for instance. You have to import it from a spreadsheet or a CSV file or a MySQL query. You don't use Tableau to make data, you use Tableau to display data. So, for our final tutorial, we're going to look at an open source GIS tool called QGIS and take a glimpse at just a handful of the thousands of features it offers. Please understand that QGIS is a truly enormous piece of software that you could spend years learning about. It has a vast library of plugins and add-ons, and it has the capabilities to not only create all kinds of maps, but to conduct really any kind of geospatial analysis you can think of. There's no kind of map that you can't make using QGIS. There's no kind of analysis that you can't do using QGIS. With a knowledge of QGIS and a basic knowledge of Python, you can really make any kind of map you like and have it display any way that you like. I'm not a GIS professional. My experience with QGIS is limited to tinkering and tutorials, but I can at least show off a few of the most basic features of the software. In this tutorial, I'll show you how to add map layers in QGIS, whether they be points, lines, or polygons, or raster data, how to sort features by color and label them, how to edit point data, how to edit vector data, how to overlay raster data, and how to make a basic heat map. Let's get started. So first I need to open QGIS, and notice that the first thing that you see here on the left is your browser window and your layers window. The browser window is how you're going to find your data, how you're going to connect to your data. The layer window is where you can see and edit the various map layers that you are using to create your visualization. For this tutorial, I will be using data from the Open Data page of the City of London, Ontario, and I will include a link in the show notes. Almost all the data we'll be looking at today is vector data, line, points, polygons, etc. Because this is a very, very low-level glimpse of what you can do with your software. Like Tableau, QGIS can connect to data in the form of anything from a MySQL query to an Excel spreadsheet to a CSV file and to a myriad of different vector and raster file types. Also notice here that in the bottom right-hand corner is an option for changing your CRS. I can choose what CRS to use in my project. I can select from many. Or import my own. And I can choose to save my map in a CRS of in whatever CRS I want. Of course, Tableau does not have this feature. Tableau only uses the WGS84 or EPSG 4326 coordinate reference system. So let's make a map. First, I'm going to navigate to my data. This is London, Canada folder, and we're going to drag a few layers onto the page. So, here are some buildings. Let's say city boundaries. Let's say parcels. And let's say sewer pipes and roadways. Okay. This looks a little bit like a mess, so I can choose just by dragging layers on top of each other or below, which layers appear over top of each other. So I'm going to drag buildings over parcels, for instance, and I'm going to change, and if I double click the parcels layer, I can change how it appears. So I can change the fill color to say something much less obtrusive. There we go, that's better. I'm going to change the roads to black. It's a little bit less ugly. I can also, if I choose simple fill, I can also change the way roads join from bevel to round. That sometimes smooths out some of the edges. I can also choose to say modify the way certain features appear by category, by some particular attribute. So let's say let's take everything out except sewer pipes. I have a map of the sewer pipes of the City of London, Ontario, and I can double click it. I can go into my symbology tab right here, go to simple line, and see it says single symbol. Well, I don't want a single symbol. I want a categorized symbol. So I choose categorize, and then I can categorize it according to a specific value. Let's go with flow type. Hit classify, and it divides it into two different kinds of pipes: sanitation pipes and probably storm pipes and storm drains. I'm guessing that's what STM stands for. I hit apply, and look, it's categorized all my pipes by color, so I can instantly see which pipes do what. So if I wish to hide this layer, I just deselect it. Now let's drag on building outlines or parcels and the city boundary, maybe the roads too. I'm noticing that my buildings display simply as unfilled polygons, so I can change that too. I double click buildings, go into I change it from a simple line type to a geometry generator, and the geometry type is polygon. I hit, actually I don't want it to be quite that. Let's do it something, color that's a little bit more subtle. Say this, peach. And there, it's filled all my buildings in, so I can see them a little bit better on the map. Now, all of these shape files, all of these individual polygons and lines and points, all have attribute data that's associated with them in the form of a DBF file in this case. Now, I have noticed that the attribute data for most of these shapefile layers is not particularly robust, but I can still see what it is. So, in order to access the attributes and see what they are, I click on the building outline. I go up to the Identify Features tool on my toolbar. I can click a building, and it will show me all the different attributes that are associated with that building. It's a structure. It was built in the year 2010. Its last edit date was 2017. Sometimes for some municipalities will give you the address of each building and more information about it. This is pretty bare bones, but it is useful to have. If I want that information to appear as labels on my maps, it's easy. Let's say I want to display the year each structure was built. I will double click on the relevant map layer, Building Outlines. I will go down to Labels. Right now it says no labels. I'll go to Single Labels. I choose my value here, let's say year, and there's all kinds of ways I can adjust how the label appears. I can change the size, I can change what unit, so this is 10-point font, but I can make it a map unit so that the label would appear, say, 10 meters high on the map, so the label will get bigger as I zoom in. I probably don't want to do that. I'm going to go to points, 10-point font. I can add a buffer to make it pop a little bit more. I can change how it appears or where it appears in the polygon. Really, I can modify every single attribute as to how this text is going to appear. So I'm going to hit OK. And as you can see, the year for all the different buildings, the year each structure was completed, displays immediately in my map. And again, you can tinker with it, you can edit it however you like. You can also change these attributes by toggling editing on and use the Identify Attribute feature. So then I navigate to the Edit Feature form, and I can change the object ID, I can change the year it was constructed, I can change what theme, whether it's a structure or feature code, any of the attributes that I can now go and modify. I can also create new shape data if I so wish. Take off the, hit edit again, I'll hit add line feature, or actually let's do a parcel. I'll hit edit, add polygon feature, right click, and here I can fill in all the attributes to that new feature. And that's a new feature on my map, and if I load it in Tableau, the map will display with that polygon showing. If I like, say I have raster data that I want to overlay, an aerial photo for instance, I can just navigate to it. Here I'm using a GeoTIFF that I took of Ontario, Canada. I'm going to hit export. It's going to make me choose my CRS. I'm going to choose the mapping one, hit OK, and here I'm going to have it appear over. And as you can see, because it's in the GeoTIFF file format, this picture contains information telling it where to display. So it is displaying correctly. You notice that all the little roads line up. And there you go. A GeoTIFF file format will contain geocoordinates, which will allow it to be integrated into a GIS like QGIS and to display in the proper location, in this case over a section of a vector map. You'll notice some of the limitations of pixelated map data, raster data. When I zoom in, of course, the resolution of this image is not terribly high, so you have some data loss, and it's just the map would be kind of unusable at this level. The final thing I'll show you how to do is connect to a CSV file or some kind of table or database. So I'm going to go into my layer feature, I'm going to go to add layer, I'm going to add delimited text layer, I'm going to navigate to my file type, in this case incidents. So let's say you have a bunch of police data, say, where the incident is recorded by latitude and longitude. As long as you have this geographical information encoded in your data somewhere, you'll be able to connect with it in QGIS and incorporate it into your visualization. So in order to connect to this, I browse to the file, as you see, and then I need to, this is very important, I need to define my geometry. So my X field is going to take longitude, of course. My Y field is going to take latitude. I'm going to hit add. And as you can see, let's hide parcels. You can see I have all this point data. Now, if I want to create a normal symbol map, I can go into symbology. I can go into categorized, and I can change it by, say, crime type. Classify. Say OK. And look, I have little points indicating each crime type. I can see information about each one. Say when the theft happened, what kind of theft it was, property crime. I can see information about the address. Of course, they hide part of the address just for privacy reasons, and latitude and longitude information. I can also make a heat map if I wish. I go to, instead of categorize, I go to heat map here. I'm going to change my color ramp to, say, magma, and edit colors. So the color 1 is transparent. Hit OK. And now I have a heat map of crime in this particular city. I'm using an example from the LinkedIn learning course of QGIS, just because they had police data available in a handy CSV file that I could incorporate into this visualization. So just want to give props to that LinkedIn learning course. So I hope I've given you the merest hint of what a tool like QGIS can do. QGIS can do many of the same things that Tableau can when it comes to visualizing data, albeit not as easily. The usability of Tableau, of course, comes with the trade-off. QGIS provides many more options for display than Tableau. In addition, with QGIS you can generate new data or modify existing data in a way that you just can't with Tableau.